Good morning. This is part three of changing out Nicad batteries in a Dewalt drill to lithium-ion batteries. Now, in part two, I kind of gave a bill of material as to what kind of parts we were going to order. And one of the parts we were going to order was this three 1850 battery holder that was going to hold all three of our lithium-ion batteries. However, we got that in and tested it, and it does not fit in the present pack for the Nicad batteries. So we changed that out, and I ordered individual holders, and I'll just put three individual holders in there, and those do fit. So I think we got that problem solved. And by the time we get to the end of this video, I will put together the complete bill of material of everything we had to order, and you'll have that bill of material. We also ran into another issue. If we were to look at the characterization we did on the new battery, the nickel battery that we got in, we had an open circuit voltage of 13.5 volts, and the stall voltage on that drill was 7.2 volts. And so with simple calculation, we could determine that the batteries, the nickel batteries, would only supply 16.7 amps. But, however, the lithium-ion batteries are capable of delivering 30 amps. Actually, they can discharge 40 amps, but for a short period of time. But they're set up to deliver 30 to 40 amps. If you were to look at the characterization of the battery, we have an internal resistance of about 0.376 ohms on the nickel battery, and that's for 10 cells inside that nickel battery. So we got a internal resistance per cell of about 36 or 38 milliohms. So if we assume our lithium-ion batteries are going to have similar resistance, internal resistance. I don't know that for sure, but I have found some lithium-ion batteries online that spec out what they have. And if I go to my lithium-ion battery that we've selected, that's this one here, to replace it, you can see down here it does show an internal resistance of 12.5 milliohms. So if it has 12.5 milliohms per cell, and we're going to have 3 cells, then we're going to have, with the resistance that is in the armature windings of 0.4 ohms, we would have 0.4 ohms plus the resistance of 3 cells, or we'd have about 0.4375 ohms of resistance. So now the battery pack fully charged is 4.2 volts. So 3 times 4.2 volts is 12.6 volts. So 12.6 volts divided by that 0.4375 ohms is going to lead to a current of 28.8 amps. So instead of the batteries being able to deliver at stall 16.7 amps like the nickel batteries that the drill is designed for, we're going to be able to deliver 28.8 amps. That's a big concern because we don't know what kind of windings we have inside the armature, and the heat is going to go up by the square of the current. So the current is increasing by 10 times or better, and so it's going to be getting an awful lot hotter, and we're liable to damage that uh, drill. So my brother came up with a circuit, found a circuit uh, that we can use to limit the current. And this is the circuit here. Our battery pack will be here. There's a transistor that is going to limit the current. And we limit the current by setting this sense resistor here. And the current can be limited by 1 voltage drop across a diode, which is 0.7 volts, divided by whatever resistance value we select here, is going to be the current that's allowed at the output. So you determine the current flow by taking 1 diode drop of 0.7 volts and divide it by a resistor value that you select up here. And I am selecting, this is the resistor that my sense is going to be. It's going to be a 0.04 ohm resistor. So 0.7 volts divided by that 0.04 ohm resistor for the sense resistor is going to allow a 17.5 amp current, and it's going to latch it at that. It's not going to allow any more than that. So if we're going to be allowing 17.5 amps, the battery or the drill is designed for stall current we know of 16.7 amps because we measured that. So we're going to be less than an amp above this, so we should be fairly comfortable. So we're coming up with another circuit here, thanks to my brother, for limiting the amount of current that is available. Some other things we need, of course, are we need the resistor here. It's a bias resistor, and I just selected that to be about 1,000 times greater than this sense resistor. And then we need now the transistor that was selected. If we go down here and look at the transistor, this is the transistor that was selected to be used, and it has a voltage base to emitter at 10 amps of being 1.3 volts max. So that changes the circuit here a little bit, in that we need to throw another diode in here. My brother's only showing 2 diodes in the circuit. There'll have to be a third diode in there. So 2 diode drops to compensate for the base to emitter voltage, and then 1 diode drop to compensate for the voltage being dropped across the R sense. So we're ordering 3 diodes here, and another diode here, and then a separate diode across the top. And I will put the bill of material for this circuit in the comments below, so you'll have that bill of material. And I will put the bill of material for the entire project in the comments as well, so you'll have that bill of material, and you can order your parts and follow along from this point forward. So that's where we're at so far. We're still waiting for the battery management system PC boards to arrive. My brother did receive those. Uh, we're waiting to get those probably in the next week or so. He's being shipped to me, and we will assemble this and get underway. So I appreciate if you would like the video and subscribe to this video and press the bell next to the subscribe button, and you'll be notified about any future releases of videos. So thank you very much and have a good day.